and at least it should contain two specific antigenic sites. And for example, regarding the T3, T3 is very small. Can we form a sandwich with small T3? No. For example, for beta HCG hormone, because this is a large protein, you can form a sandwich, okay? So, a typical example of the sandwich is a beta HCG as a pregnancy test, okay? If you use the ELISA test for the occurrence of pregnancy, you should measure the concentration of beta HCG hormone, okay? The change of beta of actually HCG hormone, because the size is large, it can form a sandwich between the first antibody that's coated and immobilized on the well and known as a capture antibody. This is a hormone, any kind of protein, any kind of analyte you want to measure, and also you have the detection antibody. So it is directly related to the concentration. It means that you have a high concentration, you have a high binding site, and also high tracer, like this. Okay? If you have a low actually concentration, and the signal and the OD is very low. So in contrast to the competitive, in a non-competitive or sandwich, we have a directly relation between concentration and the absorbance. Okay, these are, and also we have a two kind of sandwich. One of them is direct, as you can see here again. This is the immune complex. Two antibodies, sandwich, actually antigen, and the label directly bind to the immune complex. About indirect actually form, we have a secondary antibody, because this is the immune complex. Is there any tracer? No. We should add another molecule, so it is known as an indirect. Both of them are sandwich, but this is direct and this is indirect. And these are actually different form of the microtiter plate or ELISA plate. And for this today's experiment, we have some asterisk. You can detach them, and some of them actually are fixed. Okay, this depends on a brand of the microtiter plate. And after the time of incubation, and you wash, you add a substrate. Okay, wait for the reaction of the enzyme. What is the name of enzyme? What is the tracer for today's experiment? Maybe in your final exam, I ask the name of question.
TH.
H3 is analyzed. HRP, exactly. Or horse reddish peroxidase is the name of tracer or enzyme. Actually, after substrate adding or TMB, okay, you should wait to produce the color, and you should read the absorbance by the specific instrument, and the name is ELISA reader. It's similar to the spectrophotometer, but there is difference. For example, instead of cuvette, for example, in alkaline phosphatase, we use a spectrophotometer and we use a cuvette, okay? The well are equal to the cuvette, okay? But what is the advantages of the cuvette, advantages of the well? If there is a little, if you have a little amount of volume of actually your sample, you can read the absorbance. But in the cuvette, if you add, for example, 20 microliter, is it detectable in the cuvette? It is detectable? No. But in the well of ELISA, it is detectable, okay? 200 microliter. And also, for example, in a spectrophotometer, the direction is vertical. The direction is horizontal. But about ELISA reader, actually, what is the direction? The path of the light is vertical. And this is very specific and very sensitive instrument. And this is the ELISA kit, and for today's experiment, the principle I describe and assay procedure. You are at this step, okay? And after 15 minutes, you should add a stop solution, okay? When you add a stop solution, your color from blue change to yellow, and this yellow color has absorbance in a 450 nanometer. what you should actually write in your results, the title of the today's experiment is ELISA. You should write the name of type of ELISA. Which type of ELISA? Three. No. Which type of it? This is a competitive, sandwich.
Competitive.
Just write competitive ELISA and write the concentration of the T3 that you actually get from the ELISA reader. Okay?